Okay, so here we are going to look at calculation involving qualitative analysis, especially calculation in titration. Okay, and the formula here we are going to be using is CAVA over CBVB equal to NA over NB. So that's the formula we use in during titration. CA here means the concentration of acid in mole per dm cube. The concentration must be in mole per dm cube. CB is the concentration of base in mole per dm cube. Okay. VA is the volume of acid in mole per dm cube. Yes. And we now have VB is the volume of base in mole per dm cube. Okay. So we should note that. Now, there are different calculations. So the first one here is standardization. Now, in standardization, let's look at this question. It says in the reaction between sodium hydroxide and sulfuric acid solution, what volume of 0.5 molar sodium hydroxide will neutralize 10 cm cube of 1.25 sulfuric acid? From the reaction, it is obvious that it is between sodium hydroxide and sulfuric acid. So let's see a solution here. We have to write the equation of the reaction first, and that is it. So H2SO4 reacting with sodium carbonate. Now, that's a balanced reaction. So we'll get Na2SO4 plus H2O. That's the first thing we must do whenever we encounter this. You can check one of my videos on how to write and balance chemical reactions. Okay, so here we can quickly use the formula CAVA over CBVB equal to NA over NB. In the question here, we are asked to find the molar concentration, okay, of we actually here asked to find, since in the reaction between sodium hydroxide and sulfuric acid, what volume of 0.5 molar we're looking for the volume of the base, sodium hydroxide. So let's see. The concentration of the acid in the question is 1.25, so we have it there. 1.25 multiplied by the volume of the acid is 10. You don't need to convert the volume here in the case of titration. Divided by concentration of base here is 0.5. The volume of base here is what we are looking for, equal to number of moles of acid over number of moles of base. Look at the balanced reaction. The number of moles of acid is 1. The number of moles of base is 2. Okay, so if we cross multiply, we are going to see that the volume of base is going to be equal to 1.25 times 10 times 2 divided by 0.5. So let me do the calculation quickly. 1.25 times 10 times 2 divided by 0.5. Okay, that's giving us 50. So the answer is 50 cm cube, which is E. I think that is quite straightforward. So let's see another question here on standardization. It says 0.25 mole of hydrogen chloride was dissolved in a distilled water, and the volume was made up of 0.5 dm cube. Okay. If 15 cm cube of this solution requires 12.50 cm cube of aqueous sodium triisocarbonate for neutralization, calculate the concentration of the alkaline solution. Okay, good. This reaction is obviously clear. It is between hydrogen chloride and triiosocarbonate for solution. So let's see the equation of reaction. We have HCl plus Na2CO3 giving us NaCl plus H2O plus CO2. The equation is actually not balanced, so we need to add 2 hydrogen chloride here. Then this will also be 2. Sodium chloride there will also be 2 in order to balance up. Okay. Now that leads us to the next. our formula CAVA over CBVB equal to Na over Nb. Ca is the concentration of acid. We are not given the concentration, but yes, we are in a way, but not directly. The concentration of the acid Ca from the question is equal to 0.5 moles, because we are told that 0.25 mole was dissolved in 0.5 dm cube, so which is number of moles over volume, so 0.5 dm cube. So that means the concentration of acid 0.25 divided by 0.5 will give us 0.5. So concentration of acid is 0.5 mole per dm cube, or I simply say molar. Okay, so concentration of acid here is 0.5 times the volume of acid is 15. They say 15 cm cube was used, divided by the concentration of base is what we are looking for here, times the volume of the base here is 12.5 cm cube. Now equal to number of moles of acid to base from the reaction is 2 over 1, 2:1. So that means the concentration of base now is going to be 0.5 times 15 times 1, now divided by 12.5 times 2. So if we do that here, divided by 12.5 times 2, the answer is 0.3. So A is the answer, 0.3 mole per dm cube. This is quite easy. Now the next here, we have 2.00 cm cube of a sodium solution containing 0.53 gram of anhydrous sodium carbonate in 100 cm cube. Requires 25 cm cube of H2SO4 for complete neutralization. The concentration of the acid solution in the mole per dm cube is, here is between sodium carbonate and H2SO4. So we look at the equation of reaction. H2SO4 plus sodium carbonate will give us sodium chloride plus water plus CO2. Okay, and we use our formula CAVA over CBVB equal to N over NB. Now the concentration of acid is what we are asked to find. The volume of acid in this question is 25. Okay, now concentration of base was not direct, but we can find the volume. What we are given about the base is that 0.53 grams was dissolved in 100 cm cube of solution, okay, of water. So that is already mass concentration. I can simply say 0.53 grams in 0.1 dm cube if we are to convert, and that will give us 5.3. So that's 5.3 grams per dm cube. 5.3 grams per dm cube, which if I want to convert to mole per dm cube, I will divide by the molar mass. Molar mass of Na2CO3 is actually 106. So doing that now, 5.3 divided by 106, that's giving us 0.05. So we have 0.05, okay, 0.05 mole per dm cube. So with this, we can now apply the formula here. So Ca, concentration of acid, that's what we are looking for, multiplied by Va, volume of acid from the question is 25, divided by Cb, concentration of base is 0.05, we just got that now. Volume of base from the question is 15. Number of moles of acid to base is 1:1 from the reaction, 1 over 1. So that means my Ca, by cross multiplication, we are going to get 1 over 25 is going to give us 0.03 as the answer. 0.03. We don't have that in the option. And that is the answer to the calculation. Oh, I made a mistake, sorry. The volume of the base here is not 15, it is 25. So with that, it will not be 0.03. So 0.05 multiplied by 25. Sorry, not 25, it is 20. Wow, really sorry. Okay, times 20 divided by 25. That will give us 0.04. Okay, that is it. So the answer to this question is B. So that is what we have for standardization. Now we see this is also a question on titration, but here involves determination of molecular mass. So we are given that 2.0 gram of a monobasic acid was made up to 250 cm cube with distilled water. Okay, 25 cm cube of this solution required 20.00 cm cube of 0.1 molar sodium hydroxide solution for complete neutralization. The molar mass of the acid is, so here is between a monobasic acid, we don't know, but we know it has just one hydrogen, one ionizable hydrogen, and with sodium hydroxide. So let's see, look at the equation here, HX, we don't know what X is, but we know it's monobasic, plus sodium hydroxide will give us NaX plus water, beautiful, and we have CaVa over CbVb. Now the concentration of the acid, we cannot tell, we can only tell the mass concentration. Since we know that the mass concentration is the mass all over volume. So the mass is 2.0 and the volume is 250 cm cube, which is 0.25 dm cube. Okay, and that will give us 2 divided by 0.25, that will give us 8. So we have 8 grams per dm cube, but that is all we can do with this, because we don't know the molar mass of the acid. So let's see, we can, using this formula now, concentration of the acid is not known, we can use it to find concentration of acid, times the volume of the acid is 25 from the question, divided by the concentration of the base is 0.1, the volume of the base is 20, the number of moles of acid to base is 1/1. So that means concentration, if we cross multiply, we're going to get 0.1 times 20 divided by 25. So the concentration in mole per dm cube is 0.08. 0.08 mole per dm cube. Okay, so with this we can now find the molar mass of the acid, because we know that the concentration in mole per dm cube is equal to concentration in gram per dm cube divided by molar mass. Okay, so if we substitute the value for concentration in mole per dm cube here is 0.08 equal to the concentration in gram per dm cube is 8 divided by the molar mass is what we're looking for. Okay, molar mass. So now the molar mass now, the molar mass now will be equal to 8 divided by 0.08, and that will give us 100. So the answer to the question is 100 grams. 100 grams here is C. Okay, 100 grams. This is beautiful. Let's see another question. And here it says 25 cm cube of 0.02 molar of potassium hydroxide neutralized 0.3 gram of a monobasic acid, organic acid. Okay, having the general formula CnH2nCOOH. Okay, the molar formula of the acid is, or the molar mass, okay, the molar formula of the acid is, okay, we are going to do the same thing here. Solution, equation of reaction, you see that? you have the acid plus sodium hydroxide giving us the sodium will displace, is a monobasic acid, so the sodium will displace this hydrogen to give us sodium alkanoate, okay, then plus water as it's supposed to be. Okay, so if we move forward here, the concentration of the acid is not given, but we are told that 3 grams of the 0.0303 grams of monobasic acid has the general molecular formula. So we are given the mass of the acid, which we can assume is will give us the number of moles, but that's still not a problem. We can achieve that. Volume is not given here. Concentration of acid, volume of acid is not given, so we can find that. Now please don't forget that concentration and volume of acid also means the number of moles of the acid. So I can use N, the number of moles of the CV, number of moles is also concentration times volume. Okay. Now divided by concentration of the base here is 0.02. Volume of the base here is 25, equal to the ratio of the mole of acid to mole of base is 1/1. So now my N, which is the number of moles, is 0.02 multiplied by 25, and that will give us 5. So my N is 5. So the number of moles is 5. Now that we know number of moles, we can easily find the molar mass, because number of moles is meant to be mass over molar mass. So if the number of moles is 5 and the mass of the acid is 0.03, okay, it will divide by the molar mass. So now the molar mass will be equal to 5 divided by 0.03. So 5 divided by 0.03 has given us 166.67. That is the molar mass of the acid. Okay, so 166.67 for the acid. Now we can find the molar mass of the acid simply by, so this is saying that CnH2n plus 1 COOH is equal to 166.7. Now COOH, we calculate the molar mass, is 12 plus 16 plus 16 plus 16 and plus 1. That gives us 45. So that means CnH2n plus 1 will give us 166.7 minus 45. So 166.7 minus 45 is 121.7. Now 121.7. So let's look at which of the option is it. It cannot be A, of course. It cannot be B. C is just CH3. It cannot be C. C2H5 means 12 times 2 plus 5 times 1. That will give us 24 plus 5, which is 29. It is not B either. D is C3H7. That's 12 times 3, 36 plus 7. This is 43. It is not D either. So obviously the question is either I didn't write the right question, but that is how to go about it. You can learn from that. Now that leads us to the next, that's purity of substance. Here percentage purity is equal to mass concentration of pure substance all over mass concentration of impure substance multiplied by 100%. Okay, so we we see a question here. It says a solution of HCl containing 5.0 gram per dm cube. B, A is a solution of HCl containing 5.0 gram per dm cube. B is a solution of impure potassium hydroxide containing 6.5 grams per dm cube. Put A in a burette and titrate it against 25.0 cm cube portions of B using methyl orange as indicator. Tabulate your readings and calculate the average volume of A used. The equation for the reaction involved is, this. So from your results and information provided above, calculate the concentration of A in mole per dm cube. Now, concentration of A is HCl. We already given a mass concentration. We can use the concentration of A mole per dm cube. We can use the formula that mole per dm cube is equal to mass per dm cube, or gram per dm cube, divided by molar mass. So the gram per dm cube of the acid is 5.0. The molar mass of HCl is 36.5. Okay, so if we divide 5 divided by 36.5, that's going to give us 0.136. So we're going to have 0.1136 mole per dm cube. Now the next is we're asked to find the concentration of base. Now, but before we continue, this is the value of the experiment. Here you have the rough, first titer, second titer, and third titer, which you can pick any three. I can say that the volume of the average titer value here is 18.00 plus 18.00 plus 18.00 divided by 3. That's still going to give me 18.00 cm cube. Okay, that's going to give me 18.00 cm cube as the volume. So that now leads us to, so that's the volume of the acid. I will go back to the question now. Knowing our equation, which is Ca Va all over Cb Vb equal to Na over Nb, the concentration of the acid now is 0.136 multiplied by the volume of the acid is we just got it to be 18, divided by the concentration of base we don't know, times the volume of the base the volume of the base is 25. The number of moles of acid to base is 1:1. Now I want us to note something. If you notice, they gave us concentration of impure potassium hydroxide. You don't use impure value to make any calculation. You only use it to calculate the percentage purity or percentage impurity. So from this now we can see that my Cb is equal to 0.136 multiplied by 18 divided by 25. So that's giving us 0.098. So this is 0.098 mole per dm cube. Okay, so that is the concentration of the base in mole per dm cube. We got it using the neutralization formula, the titration formula. So the next question there now says percentage purity. Now that we found the concentration of base, but it's in mole per dm cube, we can find the concentration of base in mass per dm cube. How do we get that? We divide by the molar mass. And so here, what is the molar mass of potassium hydroxide? Potassium is 39, oxygen is 16, hydrogen is 1. So that will be 55 plus 1, that's 56. So I'm going to divide here by, not divide, multiply by 56. So that means the mass concentration for the base in grams per dm cube. Grams per dm cube is equal to 0.08 multiplied by the molar mass. 0.098, not an 8. 98 multiplied by the molar mass. The molar mass is 56, so 56. And that will give us 0.098 0.098 multiplied by 56, that will give us 5.488 equal to 5.488 grams per dm³. Okay, this is beautiful. Now we'll go back to the question. We're asked to find the concentration of the percentage purity of KOH. I will use here the percentage purity is mass concentration of pure all over mass of impure times 100. Now the mass of pure is the one we get from the calculation, which will go here to be 5.488. So 5.488. Mass of impure is usually given. The impure here is 6.50 grams. That's B is a solution of impure potassium hydroxide containing 6.50 grams. So we are going to have here 6.50, then multiply by 100. So I have my calculator here. 5.488 multiplied by 100 divided by 6.50 will give us 84.4. That means 84.4%. 84.4%. Okay, so that is the final answer to the questions we are asked. Wow, we have come to the end of this class. I thank you very much. I wish you the best.